Okay, so now that the water demands are set and the water tank is defined, let's now go and calculate this network. So Urbano Hydra uses EPANET engine, EPANET calculation engine, which is built inside Urbano Hydra to calculate hydraulic calculation. When I say it's built in, it means that you don't have to have EPANET on your computer at all, because the EPANET code is built inside of Urbano Hydra. But you have to know that basically EPANET is doing all the calculation. Urbano Hydra is here for drawing of the network, setting the parameters, setting the equipment, and then when you click on calculate, you can also define all the EPANET options. You see here hydraulic options, times options, energy options. I will leave everything as default. And each time you click calculate, EPANET EMP file is created and you have all the results. So basically, EPANET EMP file is created. In the background, it is sent to EPANET engine code, which is built inside of Hydra. EPANET calculate all the values, and you have all the values here back in your AutoCAD familiar user interface. And you see that I already told you yesterday, when something is blue, it means that it is newly calculated. And also, this is a really nice feature because I just clicked calculate. I didn't click save yet. You see that we have the old values shown first, and the ND means not defined, because before we had nothing, we had no results, and now we have these results. When you first click on calculate, it doesn't make much sense. But later on, when you change something and when you click calculate, you are able to compare the old value with the new value. I will show this later. So let's now just click on save. And here you can see flows, velocities, head losses, unit head losses, statuses, and so on and so on. And also you can switch to preview for the nodes, and you can see the total calculated water demands. These are the head elevations, these are the pressures, and also the statuses, but they are blank because we don't have any pumps and valves defined yet. Let's switch to section preview. And also I said that you don't have to have EPANET installed on your computer at all. But here is the EPANET EMP file, which is saved in your working folder where your drawing is saved under this file name. And if you have EPANET or basically any other hydraulic modeling software, because EMP file is standard for hydraulic modeling software, so you can go with this EMP file, let's say to EPANET, of course, but you can also go to I don't know, Bentley WaterCAD, you can go to InfoWorks, so any other software that you use. So EPANET EMP file is basically world standard. But I will of course use it in EPANET, so let's click open. And here it is. This is the same network, exactly the same with everything defined. So let's click, for example, on this node here. You see the names are as defined in Urbano. You see these demand categories. It says 3 demand categories, which are basically the configurations that we created in Urbano. So people, tourist, and industry. Or for some other node, here we have 2 demand categories, just people and tourists. Also, here you see the elevation, which is basically the elevation. What yesterday I talked a lot about this. In Urbano, we have terrain elevation, we have the pipe elevation, and then pipe can have 5 points. Top of the pipe, the top inner point of the pipe, center line, bottom inner point of the pipe or pipe invert, and the bottom of the pipe. But in EPANET and all other hydraulic modeling softwares, you just have elevation. So what is this elevation? So this is that center line elevation, So that's why I used the center line. Okay, and the demands are here also. If we check, for example, the pipes, you see here the lengths, the diameters that we set, the roughnesses, everything is here. Also the names of the pipes as well. Okay, let's close EPANET. We don't need it because we have everything here in Hydra. And let's now check the results. So you see that the profiles automatically updated with these piezometric lines showing us the head elevations. And you can see that the frame of the profile didn't automatically expand. So to solve this, just click here on redraw the profiles. And now the frames updated as well. So you can see that we have our piezometric lines showing the head elevations, and also we can go to plan as well. And maybe we can now put these hydraulic values also to our labels. So let's now change the label configurations. We talked about this yesterday, how it is easy to just change the label configurations. We can repeat it. So for example, for the sections, I will use diameter, flow, and velocity. You can double click on it. You can select it. You can click on mark, or you can make this as default. So let's set this as default. And also for the nodes, let's use name, demands, and pressures as default. And now I will run these commands for the entire system from the ribbon. Okay, for the nodes, for the sections. And now you see for the nodes, we have the node name, total demand, pressure, and also here you see diameter, flow, and velocity. And also we can check these labels to see if all the velocities are okay, if we are satisfied with this. So you can check this using the labels, but of course we have our data tables. So let's again open the data tables. Let's use our mark in plan option so we can see which sections are selected. And let's switch to section hydraulics. Okay, let's check the velocities. Let's sort it by, first of all, let's select the entire network. Let's sort it by velocities. You see that we have some very small velocities that are marked in red. And now I will show you why they are marked in red. It's not that it's some kind of error. It's just something that we call data validation. So inside of each configuration of data previews, for example, we are using section hydraulics. Let's go to section hydraulics. Here you can see this validation type. And you can see that for the velocities, this checkbox is turned on and it says validation type is between 0.10 and 1.5. You can change this at any point. And other validation types are, for example, greater than some value, less than some value, not in between, or also for some textual values for the strings. If contains something, not contains something, is the string equal to some string, and stuff like that. But this is the one that I like to use the most. So between 0.10 and 1.5. So if the value is outside of these ranges, it will be marked in red, or you can also define this color. I like to be red. So here we can see now where we have some velocities that are maybe too low. And also if we sort it by highest velocities, we can see where we have some pretty high velocity, higher than 1 meter per second. So it's in this part of the network here. And of course, in these parts of the network, we have the highest velocities. But if you remember yesterday, we defined these pipe diameters pretty roughly. I was just showing you how you can set up the diameters. And now, of course, if you want to just change the diameters, let's say on these parts here, we can select these diameters from the table. You can right mouse button on it and you can click on edit data. When you click on edit data for pipe diameters or pipe materials or pipe related data, automatically the software will open the function for setting the pipes. So let's go to edit. Okay, and these pipes that are selected in the data table are automatically selected now in this dialog, and now we can increase it. For example, here I have 200. Let's select from the same pipe group. Let's go, I don't know, with 250. Let's click save. And now you see that the data table automatically updated. Here is the inner diameter shown. Here is the nominal or outer diameter shown. And here you can see how the style also automatically updated, showing us here the bigger diameters, realistic pipe dimensions. So this is the, let's say, manual process, and you see that the velocity didn't change automatically. We have to go again to hydraulic calculation. We have to rerun the calculation, and now you can see this, old values, new values. So let's select just this branch here, and now you can see before the values for the velocity were 188, and now it will be 134. So you see here 188 was before, and now it will be 134. So let's click save, and now you see that this is changed as well. But I think this is still too much. So even though it is not marked in red, because here under section hydraulics, we define that the top value will be 1.5, but I think these velocities are still not good enough. This can be much better. Also, another great way how you can analyze these values, not by using data tables, is by using thematic mappings. So here we have the theme mappings. Again, from the installation, from the country kit, you will get all the defaults for the arrays, for the branches, for the diameters, for the velocities. We can check it. So for example, for the arrays, let's select the entire network, set legend position, let's click show, and this is now theme map for the arrays. That's how we defined the array definition yesterday. Okay, let's now check something else. Let's delete this one. Let's check the diameters. Okay, show, and let's place the legend here. So this is how we defined the diameters yesterday. So of course, all these color ranges can be set up in the configurations. We will show later, I can also create one of the theme maps as well. So this is now the theme map in different color for the diameters. Let's delete this and let's apply it for the velocities as well. Again, we will set the legend position, and this is how our velocities look like. And you see that this orange part is between 125 and 150, and we have pretty high velocities in this part of the network and pretty low velocities in these parts with the dark blue color. So let's open, for example, this one for the velocities. Let's click edit. And here you can see that you can choose the data according to which you would like to create the mapping. You can define these ranges. You can define it by defining number of limits or size of the limits or this ranges. So here for the velocity, I defined custom ranges. First we go by 0.25, then I go by 0.5. So you can basically define any ranges that you would like to see.